we are given this matrix 3 by 3 matrix Aij, right, such that AI1 plus AI2 plus AI3 equals to 1, right. Let's say that 3 by 2 matrix is A11, A12, A13, A21, A22, and A23, and A31, A32, A33. Right here, what is being said that AI when I equals to 1, A11 plus A12 plus A13, this should be equal to 1. Similarly, A21 plus A22 plus A23, this is also equals to 1. This is also equals to 1. Right. What does that mean? The sum of elements of each row is actually equal to 1. Then what is the sum of entries of the matrix A cube? Right. If the sum of entries is 1 of each row, then what will happen to A cube? What about the sum of elements of A cube? Right. So then, see, we know our very familiar matrix. What is our very familiar matrix? 1, 0, 0, 0, 1, 0, identity matrix, 0, 0, 1, which we use a lot. Right. This is very familiar to us. This matrix is actually satisfying this condition. Right. Sum of first row is 1. Sum of second row is also 1. Sum of third row is actually 1. And A cube is again equal to us, the same identity matrix. Right. A cube equals to A equals to I equals to this. Then what is the sum of all entries of this identity matrix? This is 1 plus 1 plus 1, which is equal to 3. Now, we don't need to worry much about what about the other cases. For example, A can be 2 minus 1 0, or because the sum of elements is still equals to 1. We can create lot of other complex matrices also, right? Or we can even take the general matrix. But still, we can, because the identity matrix actually satisfies this result, we can clearly see that A cube, the sum of A cube, at least for identity matrix, should be equal to 3. And identity matrix is one special case, right? So the answer is 3, but still, we want to prove this for other cases, right, for a general matrix, say for example. Then, let's say general matrix, we call the 3 by 2 matrix as A, B, C, D, E, F, G, H, I. Now, if we multiply this matrix, let's say with the single column matrix, 1, 1, 1, what we will get? A into 1 plus B into 1 plus C into 1. This is 3 by 3. This is 3 by 1. We should get result as 3 by 1. That is this matrix, right? A plus B plus C. That is A into 1 plus B into 1 plus C into 1, A plus B plus C, D plus E plus F, G plus H plus I. But it is already given that A plus B plus C equals to 1. Sum of first row is 1, sum of second row is 1, sum of third row is 1. So this should be equal to 1, 1, 1. Right. So what does that mean? If you call X as the single column matrix, AX equals to X. Now again, if you multiply this AX again with this A, we'll still get the same result, right? A into AX will become AX is equal to X. So A into X, which is again equals to X. So similarly, even if you multiply n times, 100 times, you will still always get X. Whatever is ABC. Whatever is ABC, it doesn't matter. AX is getting X when X is equal to the single column all ones. Right. Now, what does that mean? Let's say A cube is some matrix. A, B, C, D, E, F, G, H, I. If you cube this, you will get some matrix. Let that be P, Q, R, S, T, U, V, W, X. A cube is. Now, this if A cube, if you multiply with this X, we still be able to get P plus Q plus R, S plus T plus U, V plus W plus X. And we have proved A cube X is again X. So that means P plus Q plus R is equal to 1. The sum of second row is 1, sum of third row is 1. Right, what does that mean? The sum of all elements of A cube is equal to this 1 plus 1 plus 1, because this is nothing but sum of this plus sum of this plus sum of this, which is actually equal to 3. This is how we generally prove that the sum of elements is 3. But in examination, we don't need to give all these proofs. We can directly identify that identity matrix satisfies this result, so the sum of elements is 3. Right, we need to learn these shortcuts also. Thank you.